And so what this will do, and so let me actually go back to the notes. And so we'll do 5, or let's make this 4.1, create message broker, right? So what we're going to do is we're going to create a producer. Actually, I don't know what we're going to do. We'll just write it and then figure it out. So basically what I want to do here is have the UDP socket in here and have one single thread that listens to that socket and then takes each message that it receives and forwards it into one of those channels. And then on the other end, the channel would pick up that request and then do something with it. And the benefit of this is we would have a single socket that doesn't have to be shared between different contexts. And that would basically be the source of truth. The channel would allow us to route it to a separate, I don't know what they call them, but like basically, like not like computer process, but like a different consumer that can process it independently of the WebSocket component. So yeah, so let's get going. Let me just read through this a little bit. So move. I don't know. So, all right. So let's do a new Rust file. Let's rename this actually. We'll make it specific to health check. Refactor, rename, health check, network broker. Okay, and so this will coordinate everything. So let's go. So let's make a struct health check network broker, and then we're gonna have the implementation health check network broker. We're gonna have some traits, but this will have the socket, right? Actually, what will it have? It'll have, let's say it'll have the IP address. IP. So we'll have IP, and that will be it says IPv4 address. Okay, got the port. What do we actually want? So what do we actually do? We how do we open the socket? So bind to that. Okay. Oh, and then here IPv4 address, socket address new. Okay, so let me just check something right now. I'm wondering if this is if I can actually use this directly. I should be able to in the UDP bind socket. Yes. Okay, so that should work. So we'll do where is that? We'll do this, right? IP. Get rid of all this stuff. That. Okay. So we got that. We'll create a trait clone, or no, how do you do constructor? Alright, let's go back to the Rust documentation. We'll do constructor. There we go. The match control. No, it's not that. Impl. Yeah, there we go. Okay, post new, right? So there's the new content, import post. Okay, so that makes sense. It goes in import. Whoops. And we'll go like that. And we'll do health check broker. So I'm curious, right? It would be a default constructors or add text content. curious. So pub fun new post date, some box new draft content string. Okay, so I guess I do IP socket address. I do IP socket. Oops. That's not actually. We don't want an IP one. Yeah. Socket address. Cool. Got that. And this will be health check broker. Okay, got that. Put that, I guess. Trait. We don't need trait yet. So let me check something. One thing I'm not sure about, right? Like, if we open a socket, can it be closed, and do we have to do any reopening of that socket? Or, let me see, Rust, UDP socket, will Rust UDP socket auto reopen on close? According to documentation, TCP listener and UDP socket will be automatically closed when the values dropped out of scope. That's not what we're looking for. How do I close the UDP socket? What happens if UDP socket is not connected? You know, like TCP sockets which have a shutdown method with specific meanings. UDP sockets do not have such semantics. UDP sockets remain open indefinitely unless explicitly closed by the application or when the owning process terminates. Perfect. Cool. So we don't have to worry about that. We just open and use it, and hopefully it'll be good. So got our new function, and then we'll have pub, let's just say run, and then it'll do, let's see, it'll initialize the socket, right? So let's go back, get that code that does that from here somewhere. Okay, got socket address, got socket.bind, let socket equals UDP socket, and then this is going to be a self-referencing method. I forget if it has to be a reference or not. So self dot self and self what is the format? Let's see. And read self input. Okay, so why is that pub fun add text? Okay. I'm not sure. Oh, because I didn't have fun. So make this an import, and bind will be self dot socket address. Okay, so we open the socket, and then what we're gonna do is I think everything's gonna be done through channels. I think that's the best approach. So then in here we'll have, let's see, where's the channels documentation? Channel. Nope. Then we'll do concurrency, right? One second. Alright, sorry about that. Had to clean the litter box real quick, but we're good. Okay, so channel, right? So channel. Let me just copy this and see the signature for it. Copy that, go here, and we'll go into the somewhere. We'll just do this, import it. Single consumer FIFO queue communication primitives. Multi-producer single consumer FIFO. Cool. So this is a receiver and sender. So then we're gonna have a let's see, request receiver, and then we're gonna have for response sender, right? Was it sender? And what will they have, right? They'll have so we can send the raw. Okay, so we're gonna create a model for this, but yeah, let's create a model or a wrapper for this. Let's delete all this. So we're gonna do struct health check network broker message. Okay, and so this will contain a health check, what I call it, packet, right? Health check packet. Actually, let's name this payload, and then we'll go like this and import it, and then we'll do from address, because we don't have that information in the packet itself, and this will be a IP address, right? Socket address. Is it socket address? Okay. Let's see, what does socket address contain? Yeah, it'll be a socket address. I think it just contains IPM port, which is important. So socket address. Okay. And then these will just be of type health check message broker message. Okay. So we got our channels, we got our socket address we want to listen on and communicate through. We got our message broker payload model, which just wraps the actual payload and the address of the remote host. So maybe I should make this remote address, right? And then let me leave a comment. Do they do this type of comments? No. So let's do, what am I gonna say here? Socket address of remote host where the payload was sent to or received from. Okay, cool. So we got that. Got our John's health check message broker socket address. Wait, where did I put that? Okay. So I'm wondering, should I initialize these and pass them in, or should I create them and yeah, I'll have these be injected. Yeah, I think that makes sense, and I can configure them at a higher level. That might be the best approach. So we'll do that. We'll do request receiver, and then it'll be, let's copy. Ready? I'll just copy all this, right? Go like that. Got that. Request sender though, or response sender. Okay. Request receiver. There we go. And we're just gonna not do that. So let's do this. Okay. Okay, and ready? What we're gonna do? We're gonna kind of take a lot of this logic we have in here. Actually, we're gonna take all of this logic. Right? Should be good. And go like this. And it's gonna be a little different, but okay. Finding socket. Okay. What are we going to do? So I want these running in threads, but actually let's go back to health check, or network. Okay. Let's just kind of copy these and try and make them adapt them for what we need. So health check receiver. Let's just copy them both, right? Let's do that. Oops. Let's go here. Go down to here. Put these as helper methods. Pub fun, health check sender, health check receiver. Okay. This socket will just be so let's adapt this. We need self. Okay, so we got self. Got it. UDP bind. So we self dot socket address. No, it won't. Okay. So we got the socket here. And so how do we do this, right? I wonder, can I? Okay, let me see something. Previously, what I did was I cloned it. Cloning socket, cloning UDP socket Rust. Which in my mind, it just seems like that might cause issues. That I'm not aware of. So. Same one. Oh, I'm looking for, let's see, UDP socket example Rust. Okay, so maybe it's okay. So spawn move. Okay, so let's try something like that. So we'll do let receiver socket equal socket dot or clone. No, it's dot clone. Try clone. Do that. I'll do dot expect socket. Let's see, receiver socket cloned. And let's just make this consistent with everything else. And then we'll do basically the same thing down here, and we'll do sender socket. Sender socket cloned. And then we'll do what will we do? We'll take you know, maybe instead of taking self, I wonder, does this need any reference to self actually? We'll give it a reference to self anyway. I don't think it'll hurt anything, but we can do socket, UDP socket, and just get rid of this, right? Health chat packet, we gotta import that. IP, let's just get rid of that and import it. Actually, no, we're gonna modify that, so, okay. Okay, what are we looking at? So, where? Oh, okay. So it's gonna be self dot health check, self dot okay, receiver, and we're gonna do receiver socket, and then sender socket, and we're gonna have to add sender socket down here. So leave self socket UDP socket. There we go. And what is this? Value used after being moved. Why? Self dot after being moved. I guess I have to pass by reference. No? Or yeah, maybe just go like this. No? Nope, guess not. Okay, so this is the fighting with a bar checker I haven't quite figured out yet. So like move self. Self. Nope. Self. Self. Nope. Clone self. Let's see let equals self. Clone self. Why is that wrong? Cannot move. This is mute. And there we go. I just wondered why. Let me see. Reference self in thread rust. Can't pass a closure that captures a mutable reference to thread spawn. Thread spawn needs the function to be static, which means that either it captures no bars or that all bars are static. It's because the thread can continue running after the referent has been dropped. You don't need to use self in the original thread after calling start, then you can just pass self by value. Pass self by value. So it is move. We already did that. Cool. Okay, so it is just that move. So saying value used after being moved. Okay, maybe I do have to clone it then. Wait, but then why is this okay? Wait, so why is that all the reference self? Let's do receiver self. I don't know if this is good, it just doesn't seem right. Okay. And if I don't do move, does it still work? It does. But I can't probably go like send yourself dot. Why is self? Okay. So now that's that. Okay, and this will be, and then all of this can just be self dot socket address. Destination. Okay, no, it can't be ready, so. Okay, never mind. Let's just not touch that for now. Let's go to the send receiver, right? Okay. And we got our channels, right? So we'll do self dot send handler request receiver dot receive let next request equal that. next request. Go into the sender, this will be message. Okay, message. This will be message dot net address. Destination server. So I think we can just do get that, undo that, comment out. And then this will just be the message dot remote address, right? Okay, amount received, and okay. So I'm thinking maybe this is so the other thing we have to do is actually get the request object from the message itself. So we'll do, whoops, get that, and then we'll just go like this, and we'll do this, and then we'll go message dot payload. There we go. It's good. We got that. Is it looking green? There's some yellow, but there's just warnings. And then we'll go here. We'll be like, all right, what are we doing? And we'll do message, and then we'll do health, message broker message, and then we'll do receive from buffer. Oh yeah. Oh no. So this is different, right? We're gonna get a message. We're gonna get content from from the socket, and then we're gonna actually send a message to the channel, to the what is it? The response sender channel. The response sender channel. Okay. So then we got the socket, right? Or like in here, we got the buffer. Good. Socket, health check packet, header, check packet size. Okay, so actually this here, socket to send to, socket dot send to. So we're actually gonna not do this. This is actually gonna be this section right here. We're actually just gonna forward the message downstream, and then somebody else, some other component, is going to pick it up and handle it, and so they're going to decide what they're going to do with it. And so in this case, if it's this message, that whatever we're going to put downstream in the consumer of the channel will, do this for us. And it'll do it by basically just invoking the health check sender again through the channel, but with the new request, with the acknowledgement or whatever. Or whatever it may be at the time. So that's that. Let's comment this out. There we go. Go here, comment that out. Not actually going to send. What we will do is, I don't even know if I should be doing this, or if this should also be done downstream in the channel. Okay, check sync code. Okay, so yeah, for now, let's just keep this simple. I'm going to comment it out like that. Okay, keep it simple. And we're just going to, this is going to be very basic, we're just going to take response object. Okay, we're going to get rid of response object. We've got the health check packet, and then we're going to go self dot response sender dot send, and then we're going to do the health check message broker message, new. Oh, okay, so I do this, and then I go and define it, so it's going to be payload, it's going to be health check packet, and then address is going to be, where is it? The source, right? I don't know why this is highlighted like this. Oh, okay, and then dot expect health check broker receiver forwards received messages to the request receiver response sender channel. Response sender channel. Oops, damn it. I need to copy the response sender channel. Okay, got that, and then we're gonna do okay. I gotta look into that, see if that's being done properly. Okay, got that. Okay, got the TD panic message, and this would be sender self, that health check sender. Health check network broker message. Send health check broker message to okay. Do I have to do expect here? No, I don't. And this will be okay, actually, so this isn't going to be an issue. Like, we're not going to be able to stop this because I'm just hard hitting a loop. And we're going to go like this while true, and we're going to do let. Okay, so alright, so how do we do the move in a loop? So move. Let's do thread spawn loop. Can I just, let's see. Does that work? Spawn move. Loop, thread sleep. If I get rid of this, does it work? No. Okay, so I'm gonna do let new receiver socket equal this dot clone. Clone receiver socket. That should work. Cool. Loop. We'll do the sender socket. Let sender socket equals. Does this work? Ah, it does work, so I can just do that. I'm just curious if this is gonna keep, like, have a memory leak because it'll keep trying to clone them and keep. But I think once it goes down, yeah, like that should clear at every loop. I think so. I should be fine. It's kind of the point of not letting you reuse things, I think. But why does self request receive? Wait, I'm able to use self here. Oh, okay, now we need sender self. Okay. Okay, yeah, still not sure how we're gonna shut this down if we need to, but not a big deal right now. Like, do I really need to move here? Like, I don't know. Alright, let's build, see if it builds. It's the new method name cloned on health check. Got it. Okay. So I need to implement the clone method. And we can do that. What is it, like this? Derive clone. Wow, I remembered that from memory now. And health check packet will also need the clone. Whoops. Control B. Oh, it does have clone. Oh, it's because I had copy too. Alright. There we go. Yeah, I could have just removed copy here, but well, so I don't actually need copy yet, I don't think, do I? Let's just keep it minimalistic and not use what we don't need, because then you don't know what you don't need when you don't need it. You can't remove it because you don't want to break things, so. Okay. No, that's that, and let's from build again. And again, it didn't work. I'll check network broker. So it's actual. Oh, okay, right. It's gonna be. Whoops, what was it? Pound sign this. Derive clone. And then these don't have clones. Okay, what do we do here then? Can I do copy maybe? Maybe that'll work. Nope. Oh, so only the receiver cannot be cloned. Right, because can I ignore that for the clone? But can I? Is there anything in here though that needs self? Is there anything in here for self? Okay, oh, okay, so I don't actually need self. Wait, do I? What was that last one? Self. Response. This is, did I do this? Yeah, what am I looking at here? This is the health check sender. Yeah, because the sender doesn't actually do anything after that. Oh, okay. I actually didn't touch this yet, did I? Health check packet. Deserialize as the receiver. Sender. Message remote address. Socket received from. So we send. Okay. Is that right? Okay. So we'll just comment out all of this, maybe. I think. Okay. So does this in any way reference self in here? Okay, will it tell me? Yep, okay, doesn't need self. And this does reference self somewhere, but we're going to response sender. And we'll go like this. Response sender message broken. Okay, go up, see where it's broken, make this not clone. We will not clone ourselves. Get rid of that, and we'll get rid of that. I'm gonna comment that, and we're going to take these, and we're gonna do make them not public. And we're gonna just make functions. Don't need to worry about state. sender, health check receiver. Let's go here. It's just calling out all of this. Like that. Go like this. And get rid of that. Oh crap. Okay. So let request receiver equals self dot request receiver. And then this will be okay, and receiver handle. Receiver handle. Sender socket. Receiver handle. I'll check receiver. Okay, let's expect that, but response sender dot send. And I'm just gonna delete some of this coming out code because I have several copies of it. I'm gonna delete all of this. Delete this. Delete this. Go here, go here. Delete this. That. And I imagine this still isn't going to compile. I don't know why it's not complaining about anything. So health check receiver, and then we'll do self dot. And it's going to be health check receiver. Response sender. Response sender. Okay, so why can't I just don't get why. Oh, you know what? I know why. I don't know if I have to actually do that, but let response sender equal response sender dot clone. Any red response Yeah, it's fine. It'll work. I think. What's so no method name client for struct, and then there should be dot expect health check receiver succeeded. It built. Nice. Fuck yeah, dude. Alright, so now it built. Now I gotta figure out how to run it. So, okay. So let's go to main. And we'll do, this will be main receiver POC. And then we'll do a new phone main. Go in, we'll go like this. We'll do, we'll create the channels. So let's go back to the internet to see how you do that. So here we go. Shoot. What transaction SP channel? Enter import. Health check. I gotta export everything from the network broker. Let's see. Shrugged. Export. No, not export. Pub. Getting confused to your pub. Gotta do. What else? Public. So that's probably it. Let message broker equals message. Here we go. I think does this have to be pub? No, I thought it wasn't. What? Health check message group. I'll check network broker. New. We're gonna create two of these, I guess. So we'll get our socket addresses from the network one, wherever it is. Find. Where is the? Here we go. IP address for IP receiver pool. There we go. Get the socket address. Main. And we're gonna go to. Let's just copy and paste these. Pub. We'll just do pub, and we'll just use them directly. health check network broker. We get the new request receiver sender. Receiver sender. You know what? I didn't specify the type, so this will be so that's okay. Alright, let me figure out how to specify what type of channel is. Let's go here. Okay, here's a channel, map channel. Channels and ownership transference. Sending multiple values and seeing the receiver waiting. Send value. Okay, let's see what it's actually complaining about. Pub fund new. Cool, I just had the ordering mixed up. That's good. So let's just repeat this. I would put these in the functions or something, but it doesn't really matter. So we're gonna do this. So message sender. We'll do message sender 1, 1, 1, 1. Just copy this. Copy this. I'll do 2, 2, I'll do 2, 2, 2. Okay, there we go. So those are running. And wait a second, do I have to? What do I have to do? Alright, I just wondering if how I await these. So message broker 1 dot run, message broker 2 dot run, because message broker 2 and it's gonna be receiver address. Got it. So but these run, right? And let's see. Can I just do like okay here? I'm just trying to run it, see what happens. I don't know what that okay is gonna do. I gotta look into that. I'm not sure what that does. Compiling, so no there's okay. Let's just get rid of that okay then. Let's go like that. Okay, compiled and it's running. Cool. But now like we have no way of using it, so gotta do that. And it's running, so it didn't. I don't know, let's add some logs to confirm what is actually going on. So let's do print line beginning starting run process for health check network broker. Started threads for network broker print line. Health check network broker run complete. I'm gonna do print line health check message received, right? Is that what we're doing here? We are. Yeah, we're listening. Yeah. Print line response send to response sender channel. Okay. And then we'll do print line health check sender invoked. Let's print line health check message sent. Okay. Okay. So we got some logs. And then we're gonna go and we're gonna add some more here. Print line. Health check broker. Health check broker. Example. Print line. Created message broker 1. Print line message created message broker 2. Print line attempting to run message broker 1. Print line message running message broker 1. And then we're going to do attempting to run message broker 2, and then we're going to do running message broker 2. And then there we go. So I'm suspecting that that we're going to get to line 26 and see this log, but not see anything below that. It's my guess. Started threads, flip run process. Attempting the run message breaker 1. Right, so it is, it's already watched it, so what happens if so I think what I'm about to do is just going to make execution completely exit almost immediately. Okay, let's try that again, restart. Yep. So I wonder if I have to run them each in a thread in the main one, like do I have to, I feel like there's gotta be, alright, so now what we're gonna do is we're gonna put all of this stuff into 2 separate threads within here, which now we'll have 6 threads, right, because we'll have a thread here, and then we'll have 2 threads in each of these message brokers, so that'll be interesting, and I don't know if that's what you're supposed to do, but should work, and might be the only way, and I don't know, but okay, so let's just copy this. Pepper. And so message sender 1 handler handle. Okay. Go here, go like this, go here, go like that, go like yeah, go here like that. Like that, and we're gonna move this up actually. And so these messages might come out of order because they're gonna be in separate threads. So we'll do move this up, come down, running message breaker 1, and actually this won't even be hit. So we'll do message until run completes message broker 1. Finished running, right? So there we go. And I spelled finished wrong. Is that how you spell it for Finnish people? I don't know. We'll go like this, and we'll do 2. We will copy this, go like that, go like that. We're good there. Print line. Whoops. Waiting for threads to complete, and then we'll do print line, application done running, exiting. Okay, and here we'll do message sender 1 handle dot join, and we need to change this to 2. And then we gotta go here, just copy that, join it again on 2. Okay, and I guess I have to do expect. Just joined and expect 1 joined. Okay, so we will hopefully see all of the logs up until this point, and we'll likely not see these because we have no exit condition, so the threads as written will never finish in its current state. So unless maybe if an exception happens or something like that, then it might. Okay, built, that's cool. And again, I think I didn't I think I'm still not waiting here. Yeah, okay. Forgot to undo that. Let's run it again. Cool. So we got both of them are now running, but we have no way of actually sending messages. So I will go ahead and do something like that. So let's go. Let me just trigger I'll just for right now, like, I'm not gonna make it so that like it's something I can dynamically, like in a CLI send. I'll just do something real quick where I'll just send a message, and then we'll see the logs hopefully and go from there. So first we'll construct a message. So message, broker message, payload, right? We'll take the same payload we have down here because it'll be easier. And go like this, go up here, like that, and then we'll do, what was the other one, remote address, right? So we'll send it from sender 1 to sender 2, so we'll get remote address, and then, oh cool, we got it, right? So I guess we do it there, but screw it. I can make a variable and share it, but let's just receiver address, let's sender 2, let's do that. Okay, and then let message equal that. Not sure what's going on. Oh, do I have to do like new, I guess? No, I don't, because it's just a struct, but message broker message payload is what? What's wrong here? Payload instruct health check. Okay, I keep doing this. It's a little confusing because I think of structs kind of like interfaces, and in other languages, interfaces are by default public and don't have any privates. So not sure. I mean, it's nice though, because you have to explicitly make it such that you're making your stuff public, so reduces unintentional public variables. But okay, here we go. Wrong. Okay, it didn't work. Oh, I never sent it. Okay. So it's gonna be shit. Okay. How are we gonna do this? Okay, so what we need to do is we need to get the sender, right? Sender. So can I do let? No, it's not gonna work. Can I actually? Let me see if I can just do this, right? Like that, and then it's not complaining. I know it's gonna complain at runtime though, right? Maybe. Let's restart and run it. It's going to tell me things have been moved or can't be cloned. I think it's going to be the receiver. It's going to give us issues. Ooh, maybe not. Nice. Cool. Alright, so now we can do message sender 2. message sender to dot send message dot expect message sent. Okay, so it has been moved. So what we'll do is we'll do let message sender to message sender equals message sender to client dot client, and then we'll do message sender. Okay, now let's restart. See if that hopefully should. I don't know if this move here is doing that. I don't know, but it compiled though. Oh no, it didn't compile. Message sender. Okay, okay, you know what I'm gonna do? I'm gonna do message sender. I'll do test message sender, right? And then we're just gonna go up here, like this, let that equal message sender to dot client. Oh no, we want message sender one, right? We'll do message, it doesn't matter. Message sender to dot clone. Okay. Cool, compiled. And it's an infinite loop, but it's doing stuff. It's freaking doing it. It's pretty dope. Gonna stop it though and figure out what's going on. So health check vendor header 1 nonce. Response sent to response sender channel. Do I have to like clear it? Or am I doing something incorrect? I know what it is. I'm writing to the sender that gets put to the receiver, like when I'm invoking it as expected, but then I'm straight up, I think, taking whatever I received and re-forwarding it to the sender. Really stuff's happening, you know? But the header is, oh, right, because all I'm doing is, I'm not actually sending the I don't have the receiver that sends the ACK back, but I am, what am I doing? I'll check receiver, response sender. So I actually need like 2 channels. I need one for the input to go into the message broker, and then the message broker listens to the receiver, and then there's got to be another sender and receiver where the message broker sends to that channel, and then externally whatever is going to process that has the receiver for that. So that's a mistake, and it's like not even it's actually not a problem with this, right? I'm just passing in the wrong sender. I need to, so ready, watch this, ready? So we'll do, message receiver 2, oh man, the naming's really bad here because I'm getting into all sorts of shit. So, alright, so let's, let consumer sender to consumer receiver to consumer, oh no, not that, equals MSPC channel MPSC, not MSPC. Okay, got that. And instead of consumer sender to, okay, so this should be consumer sender to, okay, and we'll get this ready. So watch this. So consumer receiver to is what we will actually listen to down here. So we'll do test or consumer receiver to dot receive, and then we're gonna do let or dot expect. Oops, let me just do whatever. Leave it. Let message from broker equal that. Dot expect message to be received, and then we'll do, okay, and we'll do some more logging, print line, we'll do performing message send test, and we'll do print line sending message, print line message sent, print line line received message from broker message from broker, and we'll do whatever that fancy formatting thing is. You can find it this here. That, hopefully that fixes it. Does not look like it is. Not sure why. Debug required. Okay, so I need debug. Network, health check broker, debug, okay, and that's good. Okay, let's run it. Cool, so as we can see, dude, we did it. We got, so we fixed that loop, right? We sent the message, it was received through the UDP socket. It was deserialized into the packet structure. And then it was sent to the response sender channel, and then down here we waited for it and received it, and we logged it out, and all of the information is there, including the IP and port of the remote connection. Cool. That's pretty sick. I'm pretty happy with that. Yeah. Cool. I think I've accomplished enough today for this. Might be back, but let's get back to the notes. See what we did. So that's done. 4.2. will be like create consumers of message broker messages, and so that like would be receive, like basically they would receive the message broker message, perform handling of message, and that would be like basically that would be like whatever we were doing in the health check file, like performing the validation, processing and the request and converting it to like an ACK response and forwarding that back to the message broker to be sent back out. I'll just mention that's basically the logic in the health check file, or whatever it is. I'll just say file. I don't know if it's considered a package or a file or what, but okay, so we did a decent amount today, even though it took us pretty freaking long compared to doing this in another language that I actually know really well, but still pretty cool. Got these channels. I never really actually used channels before, but maybe once, or I don't know, but pretty cool stuff. Yes, not so. So we created a protocol that uses UDP, and the packet size is 17 bytes, not including IP overhead and other protocol metadata and things like that. But the raw packet, the application payload is really tiny, so this should honestly never get fragmented. I don't know why it would. Like 17 bytes is well below 17 bytes is well below the limitation of even the minimal limitation of a single packet size or datagram or whatever you want to call it. So yeah, cool. All right. Well, until next time, everybody. Have a good weekend, and I'm sure nobody watched, but if you did, I hope it wasn't too boring. And yeah, catch you next time. See ya.